Integration by part. That's the lesson for today. We're going to go through formal definition or actually the rule itself, and then we're going to do a few examples so that you can see how that works. Okay, first thing, let's do a review. Remember that every rule for differentiation corresponds to a rule for integration, and it's really cool thing actually. So for example, chain rule in differentiation corresponds to integration by substitution rule, okay? And then product rule for differentiation corresponds to integration by part rule and vice versa. So this is what we're going to do today. We're going to use the integration by part, which is basically corresponds to the product rule. So here is the original as a product of two functions. We're going to take the derivative of that, and according to the rules of product rule, we get the ddx of f of x gx is f prime of x g of x plus f of x times g prime of x, and you know that already. And for this, if we want to get back the original f of x, g of x, the product of the two functions, we just take the integration of the two pieces that we have here, and I've written it here: integral of f prime of x, g of x dx plus the integral of f of x, g prime of x dx. All right. Now, the idea is that we're going to solve this equation for the latter part. So let's do that. So the integral of f of x times g prime of x dx equals to f of x times g of x minus the integral of f prime of x times g of x dx. Just simple algebra. This is your integration by part. Now, to make it a little bit simpler to remember, think of it like this. If u is equal to f of x and v equal to g of x, then from here du is equal to f prime of x and dv is equal to g prime of x dx. By the way, that is also a dx there, f prime of x dx. Okay, that's what we're going to use now. So if we go ahead and replace the top, what I've underlined right here, with u and v, so what we have is integral of u dv, because this is right here. Okay, right there, right there. Okay, that's your dv. So that is equal to uv, that's f of x times g of x right up here, minus the integral of, now f prime of x, we have g of x is v and du is f prime of x dx, so we put v du. Okay, that is your du, which is f prime of x dx. It's coming from this part right here, and that, and v was g of x, which is we already have that. So the f prime of x dx, that is your du, which is right here. Okay, we got it right from there. So this is the form that we are going to use from now on right here. This is the form we're going to use from now on. This is the integration by parts. So let's go ahead and use it in the first example. Okay, here we go. Find the integral of x e to the 2x dx, and we're going to use integration by part. So the idea is this: whenever you're using integration by part, the idea is that in every step your integral calculations or the way it looks must look simpler. If you ended up getting a new integral that is very hard or more complicated than originally what you start up with, that means that the integration by part, the part that you have chosen in place of u and dv and u and v, it has to be switched. Now, how would you know that? You may not know that right away, but by practicing it over and over again, you'll get a hang of it and you can recognize it right away. So let's go ahead and do this now. So this one, easily we can just say that, so let u be equal to x, therefore du is equal to dx, and let dv be e to the 2x dx, and when you do the v, that means you have to take the integral of that. You get 1/2 e to the 2x. Okay, now remember that this is actually something that you have to just remember doing that. It's just the e function. So you take the derivative of 1/2 e to the 2x, you should get e to the 2x, okay, which you will, right? You get e to the 2x times, and then the derivative of 2x on top, that becomes 2 in front, 2 times 1/2, that will give you e to the 2x back. So that is correct integral of e to the 2x. Very good. Now, plug in there into the integration by part rule. So here it is. We have uv, u is x, v is 1/2 e to the 2x minus the integral of v, which is 1/2 e to the 2x times du, which is dx. Okay, simple as that. Now we're going to go ahead and simplify. We get x over 2 e to the 2x minus, and then the integral of 1/2 e to the 2x, you can rewrite it as 1/2, take the 1/2 out, the integral of e to the 2x times dx. You don't have to say multiplication, just dx. Okay, and we already know that, so x divided by 2 e to the 2x negative half, the integral of e to the 2x is 1/2 e to the 2x, and that's plus c, and you put them all together, x over 2 e to the 2x minus 1/4 e to the 2x plus c. Okay, this is the final answer, unless you want to put it into factor form, which is not necessarily at this point. Okay, simple as that. Notice that our integral calculation became simpler, and that's what we did. Okay, all right, let's do another one. Okay, look at this example now. Integral of x squared, ln of x dx. We want to find that integral. So let's go through it again. This time, it will be interesting to see. If you start doing u equal to x squared, it's going to get more complicated. So this one, if u is equal to ln of x, then du is equal to 1 over x dx. The differential for differentiation of ln of x is 1 over x dx, and then dv is equal to x squared dx. Therefore, v is equal to 1/3. The integral of x squared is 1/3 x cubed. All right, so, and that's v. Okay, now we're going to go ahead and plug it in, u and v. So here it is, we get equals to ln of x times 1/3 x cubed minus the integral of v, which is 1/3 x cubed, times du is 1 over x dx. Very nice. Now we're going to go simplify. So we're going to bring 1/3 to the front, 1/3 x cubed ln of x minus, we're going to simplify this right here. So that becomes x. I'm going to take the 1/3 out, And then we have x squared dx. And now we're going to go ahead and do the integration. 1/3 x cubed ln of x negative 1/3 times 1/3 again x to the third plus c. And now that we have that, we can put them all together and factor at the same time. Let's take 1/9 out. This is the 1/3 times 1/3. This is 1/9. So 1/3 x cubed. You can factor 1/9 x cubed out, and you get 3 ln of x minus 1, and then plus c, if you want to set it up like that. Okay, so this is how you do the integration for this integrand right there, and we chose u equal to ln of x. Now if you go ahead and choose u equal to x squared, you'll notice that this can get more complicated, and that's not what you want. You want to make it simpler, not complicated. This integral right here, which we have integral of x squared, that's easy to integrate. But if it's anything else, we will end up having some issues. Now, sometimes you have to do the integration by part twice. That's the next example I'm going to show you. But that doesn't mean that it's more complicated. It's just that there's no other way to do that, okay? And sometimes it's really difficult. You can't do it. All right, that is it. I will continue with more practices and make sure you check out the quiz as well.